So our study we titled "What Makes a Meteor Quackity Click?" and we were looking at monitoring the effects of atmospheric conditions on the calling activity of Quecket's river frog. So a very wise man, Stephen King, one of my favorite authors, brilliant mind, described a chorus of frogs. He said that they thumped and snapped the elastics that God had for some reason stretched in their throats. Now, if you've actually heard a chorus of frogs, I think that is a fairly accurate description of the sound that they can make sometimes. But, of course, that depends on the species too. So acoustic communication is used by a wide variety of taxa, including amphibians, but in amphibians it's just the frogs that call, none of the other ones. But it's also used by mammals, birds, insects, and even some fish species. Acoustic signals are generally used for recognition. This can be either for species recognition or even for mate recognition. It's definitely used for advertising, to advertise for a mate, see how sexy I am. And then, of course, for resource defense, such as territory, making a noise, this is my space, please don't. And for frogs specifically, acoustics is the primary source of communication. There are a few species that also use visual cues, but mainly acoustics are the important thing for them. So many males have their calling activities correlated with atmospheric conditions and environmental variables. A big part of the big reason for this is because atmospheric conditions can act as cues for the commencement of the breeding season. The atmospheric conditions are important to determine optimal breeding times so that the largest number of eggs will be able to survive, as well as the largest number of larvae will be able to reach adulthood. The biggest variables that influence frog calling behavior is temperature, rainfall, humidity, barometric pressure, and wind speed. Then, as a side note on winter breeding species, there are very few frogs that breed during the winter, mainly because frogs are cold-blooded and therefore require external temperatures. During the winter, because it's colder, they move a lot slower, easier to catch. However, rainfall and the presence of water is even more important. So in areas where the rainfall only occurs during the winter, many species breed during the winter. This can especially be seen in the Western Cape. In areas where there's rainfall throughout the year, you may still have certain species that breed during the winter because this minimizes competition for space and other resources. So our focal species here is Meteor quackity. It was actually only very, very recently described as a new species in the middle of last year. It was previously thought to be Meteor angolensis, but they have now been described as two separate species based on morphology, calls, and even molecular distinctions. They are a specific winter breeding species and extremely, extremely abnormal in the sense that they are a winter breeding species in an area where it is a dry winter. So this is the opposite of everything that we've always thought about frogs. They do call throughout the year, but the calling activity increases drastically during the breeding season as breeding and calling activities go hand in hand. And then fascinating thing about this frog, it has an extremely diverse and extensive calling repertoire, which is also only very, very recently discovered. So this is a sample of what a chorus sounds like, which consists mainly of clicks with some whines in between. And the clicks are considered the advertisement. So then they have the very specific whine note. Can be very loud. They have a whine tonal note. They have a two-tonal whine note. They have a creak. And they have a tonal note. And they even have a release call, which is produced by both the males and the females. And if you can believe it, all of these sounds are produced by this one single species. It's absolutely fascinating. So the objective of this study was to determine the effects that different atmospheric conditions have on the calling behavior of a Meteor quackity. So what makes a Meteor quackity click? The materials we used was the R.M. Young Weather Station, which was set up by the Geology Department of the Northwest University in the Botanical Gardens. That's where we like to do our studies. The weather station picked up all the variables that we used for this study. It took measurements every 10 minutes, and we used the averages within an hour for our data analysis. Then the song meter, the SM2 Plus, is the model that we used, And as Donovan explained exactly how this beauty works, lovely little machine. For the call analysis, we used only the clicks. The clicks are produced, as you can see from the graph, greatly the majority of the calls produced are clicks. This is most likely because they are the advertisement call. And the other thing is the clicks are extremely distinctive. They're easy to recognize. You will not confuse them with another species call. And as I'll explain to you, they're easy to use in the software. So the methods, as you can see there, we have the box. Sorry, where's Donovan's pointer? Yeah. Okay, so this is the box that we had. This is the song meter just lying on the ground for a bit. The box is just an extra fail-safe for weather conditions. Was mounted to a tree, and the tree overlooks a pond where we know there is a large breeding population of Ametia quacketi. We put up the song meter to record for 15 hours from 7 p.m. until 8 a.m. One day every second week. Then, as soon as we had our data, it was downloaded and we analyzed it. We used SongScope software, which Donovan also talked about. It is specifically designed for sound analysis of birds, bats, and frogs. And it is a lovely program. It allowed us to build a recognizer. This means that we were able to build a very specific recognizer, which we then could run through our recordings. And this recognizer was able to count the number of calls for us. And certain nights we had literally over 20,000 calls, and I can assure you if I had to do that by hand, I would still be counting. So this is definitely a very efficient way of doing this. However, it did take some time to find the right recognizer, and the recognizer has to be fairly sensitive to be able to pick up the most calls, but it can't be too sensitive because then you have too many false positives because there are still birds and insects calling at the same time. We did, however, go through a certain amount of the calls manually to determine false positives and negatives, and then we calculated an error margin, and that was included in our final analysis. The statistical test we used, the PCA analysis for then just the limitations for this project. Building a recognizer can be problematic for different species. They pick each other up. We had an Ametiophrinus range-rye calling at the same time. The calls sound completely different, but the recognizer still picked it up. This makes it very, very difficult if you have more than one species calling at the same time. Then creating the recognizer can be very time-consuming. We built something like 20 recognizers before we found one that really works. And then, of course, the software and the hardware are very expensive, making it difficult for just if you don't have the funding to be able to use this. And that's it. Thank you very much.